This is a quick overview reminding us how to plot points on the number plane or the Cartesian plane. It's the same thing, number plane or Cartesian plane. Cartesian refers to the inventor of this, René Descartes, and is because it's from a surname spelt with a capital letter. So this is a number plane. It is two crossed number lines. They cross at 0. They're marked with evenly spaced gradations, so the distance between each of these little lines or gradations has to stay the same on this axis. The distances between the gradations can be different on this axis and this axis, but they must be consistent for each axis. The amount that each number line goes up by, in this case an increment, an increase of 1, must stay consistent. Be very careful around here to make sure that we don't leave an extra gap when the negatives get in. Remember to count from 0 up and down, from 0 up and down. Always use rulers, arrows on each end because the number plane keeps going forever. Our x-axis is our horizontal, our y-axis is our vertical. And the other thing we do need to know is the different quadrants. This is quadrant 1, and the quadrants count around anti-clockwise, so quadrant 2, quadrant 3, quadrant 4. In quadrant 1, both coordinates of points, I'm getting ahead of myself, I'll remind us about points. Any coordinate or point on the number plane is given by, in brackets, its x coordinate, that is where it lines up with on the x-axis, and its y coordinate. So if we're asked to plot a point, point A is at -3 on the x and lines up with 6 on the y. I have plotted the point. If it's given a name, A, I would also label the point. B is at 0 on the x, -5 on the y. C is at 4 on the x, 0 on y, which means it's just going to stay there. So you see, if it's got 0 in the coordinate, it's going to be on one of the axes. 0 on the x coordinate says it will sit on the y-axis. 0 on the y coordinate says it will sit on the x-axis. Oops, I didn't label that. Point D, -2, -1. So a reminder how you plot points. Now any point in quadrant 1, for example this point here, F, F's coordinates are 2, 4. You'll see that both of its coordinates are positive. Anything in quadrant 1 will have both its coordinates positive. Anything in quadrant 2, its x coordinate is negative, its y coordinate is positive. Quadrant 3, any points in here, both their coordinates are negative, such as point D. Quadrant 4, y coordinate is negative. Did I say positive or negative here? Anything in here, both are negative. I wasn't sure what I said. Quadrant 4, y coordinate is negative, x coordinate is positive. So it's interesting to look at the differences, and you can tell from a point's signs of its coordinates which quadrant our points are going to be in. Now there's all sorts of things that we can do with the number plane. For example, if I have a set of coordinates that form a straight line, there is always an equation that will let me find the rule for that straight line, and we'll learn how to graph the line later. Oops, sorry about that. I can often have what is called an interval or a line segment. So the interval AF is the line, the straight line, that joins A and F but doesn't go any further. So an interval or a line segment is just between 2 points, whereas a straight line plotted on a graph keeps going forever, and we would use arrows to represent that. So this is an interval or a line segment. And there will be some questions where they ask you to, for example, find the midpoint of an interval. That is the one point that cuts the segment exactly in half. Now I can see it's going to be around here somewhere. To do that, you could graph it, or of course you could see if there's some intelligent way of working out the midpoint between two of these. I'd suggest when you get to that question that you graph the two, or you plot the 2 points, work out where the middle looks like it should be, and then say, well, because I reckon the middle is right there. Now that's an interesting point, pun intended, because that's not an integer value, a whole number. That is, x is at -1/2 and y is at 5. So what I would suggest you do is, if you were looking to see, well, is there a way that I could work out the middle point that cuts in half the line segment AF, you'd look at the point A, you'd look at the point F, look at the coordinates of the point in the middle and see, how did I get this? I had 6 on the y and 4 on the y. How did I get 5? I had -3 on the x and 2 on the x. How would I get -1/2? So when you get to that question, see if you can start making some predictions. So that's a reminder about the number plane or the Cartesian plane.